recording button. All right, so this lecture is being recorded. I will go over some questions in chapter 13, 14, and 12. So first question, chapter 13. How much can be paid in scholarship at the end of each month if 200,000 is deposited in a trust fund and interest is 5.6% compounded monthly? So this question is chapter 13, section 5, perpetuity. This is a perpetuity question. Because the scholarship can go on and on and on and on forever. It is perpetuity. Okay. And for this question, 200,000, that is the present value. And the question asks you how much will be paid at the end of each month. The question asks you what is PMT. The amount can be paid each month, that is PMT. You are asked for the PMT. Okay. Remember in chapter 15, and you have a formula. PMT equal to PV times I, present value times I. So you plug in the present value, 200,000. When you do formula I, you have to use percentage. And the I is compounded monthly, so divide by 12. And you should get this number. Okay. Any questions? And for question 3, this is chapter 2 question. Okay, chapter 2 question. What is the discounted value of 796 paid at the end of every month for 5 years if interest is 3% per annum, compounded semi-annually? So this value is, remember the discounted value is present value. The question asks you what is the present value. You need to use calculator for this one or formula. And make sure it is at the end mode. Your calculator is at the end mode. And then you set up your PY. PY is 12 because it is every month. 1 year has 12 months. And then CY. CY is 2 because it is compounded semi-annually. 1 year, the convention period conversion happened 2 times. And after that, this $796 is the PMT. Okay. 5 years means N equal to 5 times 12. 1 year has 12 months. So 60. And then you compute the present value. Make sure future value is 0. You need to enter 4 numbers when you use calculator. And this 3 is IY. So second PY is 12. Enter. Down arrow key CY 2. Enter. Okay. Second quit. 796. That is the negative number, PMT. 60 is term N. 3 is interest, IY. 0 is FV. Compute, PV. So you get this number here. Okay. That is a question from chapter 12. And the next question is from chapter 14. Chapter 14. The date is amortized by the periodic payment shown below. Compute the number of payments required to amortize the date. B. Outstanding principal at the time indicated. I give you a moment to digest the questions. So the principal is 15,000. The date payment 1,173. You make the payment every 3 months. Interest rate 6%. Interest is compounded quarterly. Outstanding balance after 6 payments. So this is question B. What is the outstanding principal after 6 payments? Question A asks you the number of payments required. The number of payments. So let's do question 1 first. Second quit. And then you have PMT here. This is PMT. And interest IY. You have debt principal, means this is the present value. Okay. You make a payment every 3 months. That means number of payment per year equal to 4. If you make make payment every 3 months, 1 year you make 4 payments. And interest conversion period is quarterly, so CY equal to 4. And you are calculate the term N. What is the term N? That is the question. So what is term N? Let's do the interest, enter interest. Do the setup first. Second PY 4. Enter. 档案就可以 CY is 4. Enter. Second quit. Now 6 is interest. Present value is 15,000. This is the date, is negative number, PV. You can enter, if you enter this is negative number, PMT, you enter the positive number. So I'm going to redo it, second quit. So PY, okay. So now I'm going to redo it. 6 is the interest. 15,000. 15,000 present value. I will enter negative as PMT. 1173. Oh no, that is not, that is FC. So I did it wrong. Okay, messed up. So second PY. Okay. 6 is the interest. 5th interest. 15,000. That is the PV. 1173 negative PMT. Okay. 0 FV. Compute N. Okay. So 14.3, it is said round to nearest whole number. So the answer is 15. Round to whole number. Okay. And also when I enter the number, make sure FV is 0. FV is 0. So that is question A. Next one, calculate the outstanding balance. Outstanding balance after 6 payment. Outstanding balance after 6 payment. Okay. Remember during the lecture we have 2 methods. One is prospective method. Prospective method. The other is retrospective method. So I will present retrospective method. the outstanding balance is equal to the future value of the date after 6 payment minus the future value of the annuity after 6 payment. So the formula is the future value. Maybe I will directly write down. So equal to the date is 15,000. This is the date. Maybe I will use calculator, but here I will write down some annotation. So future value of original date, future value of original date minus future value of payment made, future value of payment made, that is the outstanding balance. So I will do 2 steps. Step 1, what is the future value of original date after 6 payment? Step 2, what is the future value of the payment after 6 payment? Okay. So I'm going to use calculator. Second, quit. So PY equal to 4, CY equal to 4. I already set up, double check. PY 4, CY 4. Okay. So after 6 months, 6 payment, what is the future value of the date after 6 payment? So interest rate is 6%. So 6 is IY. N is 6 because this is after 6 payment. Present value is 15,000. That is PV. 0 is PMT. Calculate future value. It is this amount. Okay. That is the future value of original date after 6 payment. Next, I will compute future value of the payment made, that is the annuity, over those 6 payment period. So second quit, it is still PY equal to 4, CY equal to 4. Okay. And for that one, each month you make 1176.73 payment. That is PMT. And 6 is N, 6 is IY, 0 is PV, present value, compute future value. This one here. And then use this number. I'll try. I need to double check my numbers, but the method should be correct. Future value of original date. Maybe the first part I need to double check. Future value of original date. So double check the first part. Future value of original date. Original date 15000 15000. That is PV. PMT is 0. 6 payment. And the interest is 6. Compute future value. Yeah, I missed. See, this is 16401. I missed this one here. Okay, there is one here. 16401. I missed this number 1. Okay. And now I need to do this number minus this number. I will. So this sum is correct, 9094. Okay, 9094 is the answer. Okay. So that is the outstanding principle from chapter 14. And then chapter 13, we did that questions. 16, I did the questions. So that's one question about future value. Question 5. Okay, let's do question 5. Okay. For the following annuity, determine unknown value. The question asks you what is the future value given periodic payment PMT. Payment interval is 1 year, term is 9, rate is 12%. It is compounded annually. Okay. Read questions carefully. The question asks you annuity due. Due means you have to put your computer at begin mode. So BGN mode. Make sure your computer is at BGN mode. And then you make a payment every year, PY equal to 1. Interest is compounded semi-annually, CY is 2. So second quit, set up begin mode. Okay. So second began, second, set, second, quit. I repeat, to get the began mode, you do this. Second, began, second, set, second, quit. So now you have BGN mode here. And then second PY, setup 1, enter. Down arrow key, you have CY2, enter. Okay. Then second, quit. Now enter 50,000, 51,000. This is a periodic payment. So negative PMT. Term is 9, 9 is N, 12 is interest, 0 is PV, compute FV. So you get this number here. Okay. So that is question from chapter 13. So I did some selected questions. I'm going to stop recording to see if you have